So now we already have the equation for sigma x apostrophe and tau x apostrophe and y apostrophe. From that equation, we can be able to find out which plane we will get the maximum or minimum normal stress. So with that, we call that is the principal stresses. Principal stresses. So what does that mean? We want to find out where is the maximum or minimum of the sigma x apostrophe. So basically, that principal stresses occur when sigma x apostrophe E, as I mentioned, either a max or mean. And if you recall, to find out the max or mean of a function, you need to take the first derivative and make it equal to 0. Do you recall that? So from that, how can I find out? I will have it d sigma x apostrophe over which angle, which location, determined by theta, first derivative, and have to be equal to 0 to make it, to find out the max or minimum. So we can box that is in your calculus, to first derivative to find out the max or mean. So with that equation here, and let we take the first derivative for about theta. So you can have that equation become and make it equal to 0. So we have that 0 equal to negative 2 sigma x, that equation up there, sigma x minus sigma y, the first component sigma x plus sigma y over 2 if you take the derivative with regard to theta is 0, right? Because nothing depends on theta, on the first component. And then cosine negative becomes sine 2 theta. And then we have it 2 for tau xy sine 2 theta. So it will be 2 tau xy cosine 2 theta. 2 theta. And it equal to 0. So we can have that one get the divide. So we have it tau xy over sigma x minus sigma y over 2 is equal to sine 2 theta over cosine 2 theta. From that transformation, from that above equation. And if you can see sine over cosine, actually that is a tangent theta. In this case 2, so it's tangent 2 theta. And because that is a principal stress, so we got that theta instead of the general theta, we define as the theta p. P stands for principal. So what that here basically is angle of principal stress plane. Okay, so that theta p stands for angle of the principal stress plane. So with that, we can draw tangent is opposite divided by adjacent. So let me, and it tau xy over sigma x minus sigma y over 2. So if I, with that equation, I can draw a triangles here, and the opposite, that is the angle there, is 2 theta p, principal angles. So with that, we can have that components is tau, the opposite, you see that? Tau x, the top one, the numerator, x, y. And the adjacent is sigma x minus sigma y over 2. So that one here, sigma x minus sigma y over 2. So that is the adjacent component. Just make it with that. So as you can see, so the tangent at that 2 theta, as you can see there, it equal to tau xy over sigma x minus sigma y over 2. So with that, we can find out even sine and cosine from that. So we have sine, from that I can have sine of 2 theta p, sine equal to opposite divided by hypotenuse. In this case, hypotenuse is square root of tau x y square plus sigma x minus sigma y over 2 square, basically square root, because the right angles is here, right angle is there. So from that we can have sigma power equal to tau xy divided by square root of tau xy square plus sigma x minus sigma y over 2 square. And we have it sine, cosine, 2 theta p, adjacent, so it will be sigma x minus sigma y over 2 divided by square root, so adjacent over hypotenuse tau xy square plus sigma x minus sigma y over 2 square. So that from the tangent we can be able to find out the sine of 2 theta p and cosine of 2 theta p. And as you can see, when you want to find out what is this angle, actually with the sine we have 2 roots, 2 solutions. So 2 root from that one, we have 2 root. 2 solution, when you find that out with the sine and cosine here, 2 root. And that 2 rows here, we call it at theta p. But the first one, we call it p1 when we get the maximum. That stands for maximum normal stress. And then we also, the other root is we call theta p, but p2. And in that case, we get the minimum stress. So if you go back to the review, there are reasons that we review in the count member. Here, as you can see, at sigma, at 0 degree for the count member, in principle, it at angle theta equals 0, and 90 degree, that is the minimum, also principle, but that at the minimum. So 2 root, as you can see there, because actually that is a sine curve, right? So with that, we have 2 root, and that theta p1 for the maximum principal stress and minimum principal stress. And with that, we can rewrite with the equation there, after to take the derivative, the 2 root theta p1 and theta p2, and we also have what is the corresponding stress, that is sigma 1 and sigma 2, sigma 1 and sigma 2 we have, because there are 2, so you have sigma x plus sigma y over 2 for the principal spread, plus or minus square root of sigma x minus sigma y over 2 square plus tau xy square. tau x squared. So that equation is to determine the principal stresses, and there are two, 1 and 2 for maximum and mean stress. And then we can go ahead to define what is that about. So where sigma 1 is the maximum principal stress, and of course sigma 2 is minimum. And then what is the tau shear stress at the principal stress plane, at the plane that have principal stresses? Actually it equal to 0. So what does that mean? You have no shear stress on the principal stress plane. No shear stress on the principal stress plane. That is very critical important. Why that? I'll go back to very curve here. Very first review that you have, and you can see when theta equals 0 with the sigma max, the tau, the red line, is 0. And then when sigma mean at 90 degree, tau also 0. So it at the principal stress planes, tau equal to 0. Keep that in mind. So here, so from that, we this video we go over to find out what is the principal stresses and how can we locate that is theta p, and at that principal stress plane, either plane 1 or plane 2, then the tau x apostrophe y apostrophe on that plane equal to 0. In the next, we will go over the maximum for the plane shear stress, which is tau, and then we can continue to practice worksheets A and B.